Hello, welcome to my home. My name is Federico. Today I will be telling you everything you need to know about gas exchange. This is my friend Timoteo. He is going to be frog one day, but right now, tadpole. He has external gills. Let's take a closer look. My gills are not that, you see. My gills are hidden under a flap of skin. They are called internal gills. They work the same way though. Oh, you may be wondering, how do I get oxygen into my blood? It is easy, like the animal physiology midterm.
Oh, Federico, I must complete my metamorphosis now.
How do you mean?
That is a topic we cover in another lifetime.
Anyways, here is how I breathe. Oh, pretty. I take in water through my mouth and this passes over my gills. So water goes this way. And blood in my gills flows in the opposite direction. This is called countercurrent exchange. These
are red blood cells. They have hemoglobin and can carry oxygen around my body.
Oxygen from the water diffuses into my blood from a high pressure area into this low pressure area. These numbers show the pressure difference of oxygen in the water and my blood. The greater the difference, the faster the diffusion. The pressure remains constant throughout the exchange. But no, this is not the way for all animals. Let's go see my friend Valeria.
Howdy y'all, my apologies. I am heavy breathing because I was just dancing with my dance group. Federico told me y'all were here to learn about how I breathe. I am not like him at all. I am not as efficient as him in gas exchange. Air flows this way in my air capillaries. My blood flows this way. It is very similar, except do you see the difference? They are going perpendicular to each other. This is called cross-current exchange. Since my blood and the air do not flow in opposite way, it's not as efficient. Right as my blood comes in, near my air capillaries, oxygen diffuses from the high partial pressure into the low partial pressure. This is how gas exchange happens. Look at the numbers change. See how the numbers are vastly different from when they enter and leave my capillaries? My difference in partial pressure of oxygen decreases throughout gas exchange.
So, you've seen all of my friends now. I think we are done.
Hey, the name's Rebecca, and I'm gonna teach you about how I breathe. As you can see, I need my oxygen tanks. I do not have gills, I have lungs. I need oxygen just like everyone else. However, oxygen gets into my blood in a completely different way. Tidal exchange.
Hey, your type of gas exchange is nothing compared to mine.
That may be true, but like, at least I can breathe out of water. Alright, time for my close-up. Like, this process occurs between my alveoli and my blood capillaries. And like, this is the wall of my lungs. Do you see how the air comes in and goes swirly swirl? Like, I love it. There's not a lot of space for gas exchange though.
Yeah, this is why it sucks.
Like, my body compensates by having a lot of alveoli to increase surface area for gas exchange. And like, this process is called concurrent exchange and is the opposite of countercurrent. Look at these numbers. What's special about them? My blood enters with a partial pressure of 0, whereas the air enters with a pressure of 100. Oxygen quickly diffuses across this large gradient into my blood. Eventually, the difference becomes less and diffusion is slower.
I am grown up now. I have evolved. Let's review at the beach. The partial pressure of oxygen in our blood when it enters the site of gas exchange is 0, whereas the partial pressure of oxygen that leaves Federico's lungs is 75. Compare this to malaria. The partial pressure of oxygen that leaves her lungs is 65. Finally, the partial pressure of oxygen leaving Rebecca's lungs is 48. This is the order of most to least efficient.
Muchas gracias, amigos. I have learned so much. This day has been amazing. Oh look, it's time for dinner. Let's go to my place.
Wait, my mates have once again abandoned me. Greetings, I am but a small insect. I do not breathe in such complex ways as they do. All I have is a system of internal tubes called tracheae. Gas is exchanged through simple diffusion with the atmosphere through external openings of my tracheal system, called spiracles. Carbon dioxide also leaves through these openings. Now please excuse me as I try to make my way towards the dinner, which I am obviously invited to. Cheers!